Your screen is visible.
Great. All right, so let's start. First of all, thank you everyone for joining in. Before we get started, a little bit about me. I'm Raj. I work as a software engineer at InVideo, where I mostly work with Elixir, Phoenix framework, TypeScript, React, and more recently Rust. I also maintain a technical blog on my website, rajhans.com. And very recently, I have started co-organizing the Rust Mumbai monthly meetups. So if you want to chat about anything interesting, that's my Twitter handle right there. Moving on to today's topic. So right in the title of the presentation, there is this thing called dependency management, right? What does that mean? So dependency management, it's a age-old problem of software development, wherein you have your all of the software, it depends on all other software, right? And solving those problems, it's like solving a Rubik's cube that constantly keeps changing colors. Because just when you think you've got it all figured out, a new dependency pops up and an old one updates, things like that. To understand this, like imagine you're hosting a dinner party, right? And your guests are your software dependencies, and they all need to play nicely together, right? But some of them, they have very specific needs. One guest, let's call him Python 2.7, refuses to sit next to Python 3. Another guest, TensorFlow, insists on bringing along an old friend, CUDA 10, even though your house has already been renovated for CUDA 11, things like that. If you're working on a project that other developers are also working on, this causes multiple problems, right? First of all, in your project's documentation, in the README files, setup files, you need to mention things like if you're using Mac OS, then do this. If you're using Linux, then do that. If you're doing Windows, do something else only. The reason is because the method of installing the dependent software, it's that is needed to set up the developer environment for your project. It changes from system to system. So if you have tried to follow setup instructions for some open source repository or even your new company's project repository, you'll feel the pain. You'll relate to this. It's a nightmare, right? And secondly, as software engineers, we work on multiple projects, multiple code bases. If each of them has different dependencies, then or different language versions even, then our life becomes very difficult. Right? It's not very practical to update your system or your user environment every time you want to install a particular dependency for a given project. And because the reason is a dependency can only be required by a specific project, you don't need to have it available system wide. And secondly, you want your environment to be shareable with other developers on your team. Asking them to update their global environment with this or that is not the best thing to do. And if you relate to these problems, then you're at the right place. Even if you don't trust me, you will for sure run into something like this in one time or the other in your software engineering career. So some of you might say, well, ASDF can solve it, right? So why do I need anything else? That is partially correct. If you don't know what ASDF is, don't worry. It's basically a tool to manage multiple language runtime versions, right? So it has a plugin system wherein there's like a different plugin for different languages, like ASDF Node, ASDF Python, ASDF Elixir, things like that. And how it works is in your project's root folder, you have this file called .tool_versions. Okay. And that file kind of defines the version of the language runtime. So for example, over here, we have the Erlang and Elixir runtime versions specified. So whenever you come into this folder, ASDF is going to try to load those particular versions of those languages for you. That does sound good, to be honest, but there are definitely multiple limitations with this approach. First is that sometimes your languages, they have dependencies, right? So for example, Erlang, it requires ncurses, it requires OpenSSL while the installation. And then those things you have to manually install separately, right? And the installation mechanism for those things, it changes time to time from system to system. And then again, you have to definitely make sure that you install the exact compatible version of those dependencies. Otherwise, it won't work. Otherwise, you will be in a nightmare scenario trying to haphazardly Google search random errors that pop up one after the other while you're, wiping off tears from your keyboard. I may or may not be speaking from experience there. And then next up, yeah, if your project depends on tools like Postgres or FFmpeg, then the correct version of that also must be globally installed in the operating system. And then again, the problem is same. Installation for that depends on system to system. So you go into this deep rabbit hole where you keep searching for how to install this for Windows, how to install this for Macs, things like that, right? Finally, the plugins, the ASDF plugins, they need to be installed manually, which isn't a problem per se, but would be nice if we didn't have to do that, right? What if I told you that there was a universe where we could specify the dependencies per folder and not just the language runtime dependencies, right? Each and everything, right? All the transitive dependencies that your dependencies have, we were able to specify those. What if for a project we could ensure that we have isolated, reproducible environment for every developer, right? No matter what things are installed on their system or what their system is. And what if we didn't have to spend a week just setting things up and fixing dependency errors when we start on a new team or start on a new project, right? So this is where Nix enters the game, right? So basic question now, what is Nix? When I asked the same questions, I naturally searched it on Google, tried to understand what it is, went through some documentation that is available. Let me show you what it felt like understanding what is Nix at the start, right? It was very confusing because some say it's an operating system, some say it's a language, it's a package manager. I have felt very confused. The reason for this is because, put it simply, Nix is a lot of things, right? At its core, Nix was created as a purely functional package manager, right? Trying to solve the age-old problem of dependency definition management for the software. And since then, it has evolved into full-fledged Linux-based operating system called NixOS. And then along with that, Nix is also a domain-specific programming language, right? So Nix refers to all those different things, which is why it becomes very prudent to decide what is the goal for today's session. What do we intend to take away from this, right? So to start it off, the goal is not to go deep into NixOS. Okay, it's not to understand the intricacies of the Nix language or to go into the theory of Nix magic craft and things like that. No, the first goal is to convince you and show you how Nix will make your life easier with reference to these dependency management problems and how it will make your development workflow way better. Then the second goal is to just get you up and running with Nix. Okay. Once you're comfortable at that place, then you are free to explore the rest of the ecosystem after that. Okay. So we are going to focus on the Nix, the package manager, not the operating system or even the language. We will just learn enough of the language to just get us to a place where we are ready to go in terms of achieving these goals. So, okay, let me show you a sneak peek, right, of what kind of dev workflow that makes life easy I'm talking about. For this, imagine you have two projects. Project one is an older project which has a hard dependency on Elixir 1.14 and it needs Python 2 for some reason to work. It can't work with any other version of Elixir and Python because of the legacy code. And then other one is a greenfield projects which you want to use. You want to use the new Elixir version 1.15 and let's say Python 3.9. Okay. And you're going to be switching back and forth on working on these projects. So you need the environment to change as you go. I have this set up already. Let me show you. Okay. So this is, I'm in the project one directory. Let me do Python version. So if you can see here in this directory, the version of Python is 2.7. Similarly, if I do Elixir, the Elixir version is 1.14. But at the same time, if I go to this directory called project 2, the Python and check the Python version there, the Python version is 3.9 over there. And similarly, if I check the Elixir version, it's 1.15. So I didn't need to do anything like Python 2, Python 3. I just typed Python and I got that particular version. And this version, this Python installation, it's isolated for these particular projects. So if I go to my home directory and I type Python version there, it's a completely different version. This is the version that is globally installed on my system. So when I run any Python code in project one or project two, it's not going to use the global Python installation. It's going to use the local isolated reproducible environment Python installation, right? Apart from that, another benefit that I get in the workflow that I was saying is custom commands. Okay, so I can just type help and get a help message for project one. This can be anything. This can be a README or whatever commands that are needed for a newcomer to the project to get onboarded, started, things like that. If I go here and type help, you'll see a customized message for project two, which is again a different one, even though I just typed help, right? So this also opens up a lot of avenues. You can have different scripts wherein if you just type, for example, if you just type run dependencies, it will install all the dependencies that you have for that particular project. And no matter if the project is a React frontend, Elixir backend, Python, Django application, I'll just go and type run dependencies, and the custom scripts that have been installed will take care of the rest of the things for me. Okay. And finally, whatever environment variables are needed, they get loaded in your shell itself. So imagine there's a environment variable called custom envar. Okay, custom envar. So over in the project two folder, I can see the value is project two specific. Again, if you run the same code here, it will be project one specific. So just going in and out of the directories, I can load and unload all the complete environment variables, all the complete scripts that are needed for that particular projects. Running this will give me project two. Yeah. So that is the ideal workflow. We'll see some more, niceties that we get with this as we go ahead. But the goal of this session is to get to a place where this workflow is doable for all of us. We'll start from scratch and we'll build up to this and learn everything that is needed for this along the way. But to start off with, we will need to understand some basics, basically some terminology that gets used in the Nix world. So a derivation to start with, right? A derivation in Nix is basically, it's a definition of a build, okay, which takes some inputs and produces an output, which are the packages, okay? So you can write your own derivation, your own package, or you can use ready-made packages. And for common tools and languages, ready-made packages are readily available. Then next terminology is Nix shell, which is a temporary environment in your shell where the build inputs of the derivation are made available. This might sound confusing, but hold on. So for example, if we have a derivation that builds Python 2, then the Nix shell will build it. And inside that Nix shell, I will have access to Python 2. And by default, a Nix shell, in a Nix shell, it looks for a shell.nix file, which is used to find the derivations that it needs to build and expose to that particular environment, right? So yeah, that's pretty much it. To start with, we will also be using two useful tools in addition to Nix that make the whole thing better. Let's see what are those. First is dir-env. Okay, you might have heard about it. It's basically a tool to automatically switch between environments based on your current directory. So before each shell prompt, dir-env kind of checks for the existence of .envrc file in the current directory. And if it does exist, it will basically load it into the bash subshell that you are in right now. And all the exported environment variable scripts, they get captured by dir-env and they are made available to the current shell. One really neat thing about this tool, dir-env, is that it is aware of Nix. So you can just put use Nix inside the .envrc file and it will know how to update the current shell to behave like a Nix shell. Secondly, we will also be using niv, which kind of makes it easy to work with Nix for adding and updating your dependencies. So it creates this file called sources.json, where it stores the data for your packages, which kind of just allows you to specify versions, etc., in a simple JSON file, rather than having to write the difficult Nix code just to do that. Okay. All right, that is enough theory. Let's try to get our hands dirty. Our eventual goal is to reproduce what we saw earlier in the sneak peek. So what we will do is we will start from the scratch. Okay. I'll create this new directory called new project, cd into it. Then to bootstrap a Nix project, I will run this command called niv init. Okay. This is from the niv tool that we saw earlier. Also, one more thing. I am doing this assuming that Nix, Niv, and Deren, these three tools, they are installed on your system. It is pretty straightforward to install them. I have given the links as well as the command to install these three things. Once you are installed with that, you can just follow whatever we are doing here. But yeah, for now, just we'll go through it. We'll see what's happening, and then you can do it as well. Cool. So I've run Niv in it. Let's see what it has done for us. Opening up a VS Code. Okay. So it created these two files for us, right? First is sources.json that we talked about. It's if we go and open it, it's basically it has the data for the sources from which you're using to install the dependencies, right? In this case, there is something called NixOS Nix pkgs. If I open this in, yeah, this is the repository. And inside the pkgs folder, you will see that whatever packages are there, games, development, they are defined over here. So you can just use all of this. And there's a interface, a UI to search for all these packages, which is called the NixOS search website. So here you can just type in the tool and you'll get the result, whatever packages are available. The second file that we have is the sources.nix file. This is basically the Nix code that is generated by the Niv tool. It has the logic that is needed to use the JSON file that we have defined. We don't need to go deep into this file because, as it says, it has been generated by Niv, and the primary purpose is to allow using the JSON file. Cool. Okay, so let's try to go into the Nix shell, right? As we saw, Diren allows us to kind of just type use Nix and it will do the rest of the things. Let's do that. I'll create a file called .envrc over here, type in use underscore Nix. And what now, if I open this folder, what should happen is Diren should detect that, hey, this guy is trying to load the Nix and it should load the Nix shell. Let's try to do that. So I've typed direnv which is basically allowing direnv to access that particular env file. And there I'm getting this error, okay? It says that no such file or directory is available, okay? So remember in the previous slide, we saw that Nix shell, it tries to load definitions from a file. And it tries to load it from the shell.nix file first, and then default.nix file. This error is basically saying that it was not able to find that particular file. Let's create it. Shell.nix. Okay. So I've created this file. Let me try again. A different error, that's progress. So, okay, the shell.nix file over here, which is empty right now, it is responsible for defining what all things will be present in your shell, right? Now the question is how to define it. How do I write in this file that I want something loaded in the shell, right? For example, how do I write in this file that I want to Python 2 to be loaded in my shell? Let's try to explore that. To achieve this particular goal, we'll need to understand a few different things in the Nix programming language. Again, the primary purpose of this talk is just to understand enough to get us started, to get our work done. You can dive deep later as well. So I want to write that I want Python to load it in my shell. The first question is loaded from where? The answer to that question is the sources.json file that we just created using Niv. So to do that, the next logical thing is we'll have to import the sources into our shell.nix file. And to do that, this is the code. The language that this code is in is Nix, the Nix programming language, which is kind of a subset of Haskell. The code over here, what it does is pretty simple. It imports the sources.nix file and basically binds it to the source variable. And then it imports the Nix pkgs inside the sources file, and then it binds that to the pkgs variable. The let keyword here, it just marks the start of a let expression, right? Which allows us to bind values to names in the Nix language. Then whatever values that we bind here, they are available after the code that we write in after the in keyword, they are available there. Cool. So let's do that. Let's import the sources that we have just defined. So sources is import, the file is over here. So /nix, and Copilot is helping me. That's good. Okay, yeah. And packages is import sources dot nix packages like this. And then finally we'll have in. After in will be the code that will use this packages to say that I want Python 2. If I just press enter now, I'll get a different error saying unexpected end of file because the code till now is incomplete. So next up, third thing we want to do is actually define the shell environment using the sources that we have just imported. How to do that? The answer to that is we use something called mk shell, which is basically a function provided by the nix packages, nix packages that allows us to create a new shell environment. Okay. As we discussed, the Nix shell environment, it's like a sandbox where you can run commands and programs. It has its own set of environment and installed packages, which are completely isolated from the rest of your system. And this is the function that takes a set of attributes that defines the environment and uses those attributes to create the said environment, right? So it looks something like this. We have the let in block that we have defined, and after that we start the definition of the particular shell that we want using curly braces. So in our case, we will be using two MK shell attributes. First is build inputs and shell hook. Let's quickly understand what these do. Okay. The first is build inputs. It's very simple. As the name suggests, it is used to specify a list of packages that you want to install in the shell environment. So you pretty much just mention the package name, and that package name you can get from that Nix packages website, right? Actually, if you add another source, you can do anything that your source will provide. But for starters, Nix packages that is already there is pretty much good enough for us, right? Cool. So let's do that. Let's see what the syntax is. So after the in, we want to have the nix packages.mk shell, and inside that build inputs attribute. Let's add that. Okay. So over here, what we want inside this is packages.mk shell like that. And we want to use the build inputs attribute like this, which is an array. And over here now we can use the packages variable that you see here, right? So let's do Python 2 first. Cool. So packages dot Python 2. If I just do this, go to my shell, press enter, it will try to update the new, it will try to use the new shell.nix file. And if I do Python version now, I get Python 2.7, right? Let me remove that. Let me keep it empty. Loading the new thing again. Now, if I do Python version, it's pointing to my global system-wide installation, right? So yeah, we can pretty much define any tool, any programming language, any version of any programming language that we want in this build inputs. With this just 4 files, you can achieve absolute reproducibility in across your across your developer systems. Not just the tool, as I said, also the transitive dependencies of the tool. So for example, a lot of languages, they depend on GCC. And if you're using Mac M1, you would have encountered into errors of GCC, CLang, and things like that. So I can even say, I can just type here. Right now, if I say which GCC, it will point me to user bin GCC, which is my Mac level GCC that is there. If I type here pkgs.gcc, then just press enter, it will try to load the new GCC. So now if I do with GCC, you can see that the GCC that is being loaded is separate one, isolated one for this particular project. Right now, I've just typed GCC, but you can also type specific versions, right? Let's do that actually. Let's go here and say Python. Okay. So there's Python 2 that we just tried right now. There's Python 3.9 as well. Let's try that. It's basically copy this, go here, and instead of Python 2, just put in Python 3.9. Press enter, it will load the new Nix file. Do Python version, you'll get Python 3.9. While you're doing this the first time, it will take some time to load because it will download the necessary files for it to build, and it will actually build the whole thing. But after that, it should be pretty much smooth sailing, as you can see over here. Some more things. Let me do ffmpeg. ffmpeg. Let's say I want ffmpeg 6. Copy that. Go here. pkgs.ffmpeg 6. Press enter, and then do ffmpeg version. You'll see that I got the version 6.0. And for 4, if you want 4, then again, just do 4 and press enter. You'll get the 4 version. It's literally as simple as that. Imagine, like, whenever a new team member starting on your team, then you don't have to specify that, hey, we need this version, that version. You can just they can just import, they can clone the repository, have Nix installed, and Nix will take care of everything else for this. And then later on, when you as a team decide to upgrade the version, you won't have to tell everyone, right? You just update the shell.nix file and the whole team is just ready to go. If you have any advanced requirement, like I want this very specific version of something, that is also completely possible using the same workflow. And yeah, that is build inputs for you, right? Next thing, yeah, that was the demo. Next thing I want to show is the next attribute I want to show is the shell hook attribute. Okay. So it's again very simple. It's just a string of shell commands that you want to run every time the shell environment is entered. It sounds very simple, but it opens up a lot of possibilities to make our lives easier. For example, the way of specifying that is you just add another attribute. You add shell hook here. This is your string, and inside this you can type any shell script uh, command that you want. For example, if I type export my var 123 is hello world, then just press enter and try to echo it, you'll see that it loaded that shell script over here. So this does sound very simple, but this opens up a lot of opportunities. Okay, let me show you an example that helps me every day. Let me add Elixir as well over here. So to add Elixir, what we'll have to do is go to Nix pkgs and just find what kind of Elixir version that you want. In my case, I should have it already loaded over here. Okay, this one. So let's say I want R25 Elixir 1.4. Press enter. I got Elixir. Now, if I do IEX over here, I type something, let's say io.inspect, hey, and I close this IEX again. Now, if I press the up arrow, I won't get that history because by default that history is not stored, right? But I would ideally like to get like that history to be stored so that I can just reuse it when I restart my server and things like that. So if I search how to preserve IEX history, the answer to that is they ask you to export this variable all flag, right? Now, I can either do this in my ZSHRC file, which is not ideal because that file is global and it will be enabled everywhere. And after some time, your ZSHRC becomes so big that you're afraid to remove things from it because you forget why you have added something and what will break if I remove it. In this case, what I can do is for this project, I can just add that env here and copy the wrong thing, and it will just start working, right? So whenever I open this project, my shell history will be preserved. Another example for the shell hook I can think of is if you're using Python in your project, you can activate virtual environment. You can put the activating of virtual environment command in your shell hook. So whenever you enter in this directory, you will completely land into your virtual env rather than having to put one extra command that you have to put. Let me show you one more cool thing that you can do. What I'll do is I'll create a file here called a folder called bin, and inside I'll create something called, I don't know, say hi. And over here, I'll just do echo hi there. All right. This will be a bin, a bash file, and I'll make it executable. Okay. chmod say hi. So now this file is executable, and inside my shell hook, I will update the path to say path is the bin and then the existing path, basically, right? So now if I load the new variable, if I do say hi, that particular script got loaded and I can just use it directly. I can just type say hi and that script will be executed, right? So this does open up a lot of possibilities to make your life better. So for example, what I've observed is for quite a few times, I have to run long running commands, right? And if you know Rust, the compilation time can be pretty long in that case. And you just have to wait until it finishes compiling or running. And what used to happen is, instead of waiting, I would do something else. Like I would work on some other project or maybe browse Twitter, and then I'd get lost in doing the other thing. So I would have to come here, check again and again, is it done? Is it done? And switch to this screen and check if the compilation is done. So for that, I have this one little script that I'll show you. Let's call it notify. And the script is, give me a minute. Yeah, this is the script, right? Uh, it is a very simple script. Again, basically what it does, this OSA script is a Mac OS API to display a notification. Let me show you what kind of workflow it allows. Let me make that file executable and then simply notify, say hi. So, okay, that did not run. Just a sec. Notify is there, say hi, all right. Okay. If I do, okay, my notifications are disabled because of Zoom. But what happens is you get a notification once that particular script is done running. So that is so simple, but so convenient, right? Once that script is running, I'll get this notification that, hey, this script is done and I can come back and do this. Because all these files are checked into your version control, all the developers on your team, they have access to it, and all of them have seamless experience, which saves the developer hours and increases dev productivity. Okay. And similarly, you can add whatever files you want over here. We saw the help one in the sneak peek. Let's try to reproduce that. So this is a file which is simply has some colors and prints a message over here. And if I again, make it executable and type help, I will get whatever I have written over there. Right? So yeah, right now we are at a place wherein yeah. Right now we are at a place wherein we have fully reproduced the sneak peek that we saw at the start. And all of that was done in only these many lines of code. And yeah, so with only these many lines of code, you can also have the same thing. After this, I'll show you. So yeah, as I said, I work on the Phoenix framework a lot. So I constantly find myself creating new projects to play with and adding the same things again and again, like Credo, Dialyzer for Elixir and for Phoenix. So what I did was I created a starter repository over here, Phoenix Elixir starter, which uses Nix. That one has a lot of cool things in it that I would like to show you. Yes, so this is the repository. It has all these features, like the Nix is set up over here. If you see the shell.nix file, it does the same thing that we saw. There are some additional things. So for example, over here, there's a conditional code, which basically says that, if I'm running in Linux, then add this iNotify tools. If I'm running in Darwin, then macOS M1, then add these things, because Mac's core foundation and core services, they don't play well with your normal Elixir and Rust code, because you'll have to run it inside Rosetta, which is another headache altogether. This kind of makes it use the local isolated Nix code, the C, Clang, and GCC code, just saving you all of that headache. Then over here, I have some shell hooks, which are defined over here. And in that, I have things like, I'm isolating the mix to run in the particular project directory, and other things like, this shell history enabled, things like that. Then finally, I'm doing the same thing. Path is bin path. And in the bin folder, I have a lot of scripts that make my life easier, so to speak. Yeah. And what those do is, let me show you. First is, this is a starter project. So if you go into lib over here, I have it named like Phoenix Starter Web or things like that, right? But if you want to use a starter, you want your own project name, right? So I just wrote a script for that, rename Phoenix project, which does whatever I wanted. And if you're using this, you can simply go in and type this command, rename project, and module I can have my, sorry, I'm in the wrong, yeah. Rename Phoenix project, and module I can have my project, and the OTP application name will be my project. Then just doing that will run that particular script. And if you see, everything was done to have me ready to go with my project, Phoenix project. Apart from that, it also has a CI, GitHub CI, which uses Nix cache. So very cool thing over here is this shell.nix file. It's not just for your development environment, but you can also use it in your CI to cache things and to have like a fully reproducible setup. So if it works in your development environment, your CI is going to pass because the environment is same, right? That is also a very cool thing. Apart from that, let's see what else this has. Oh yeah, run commands. As I was saying, I can do things like run deps, and it will install the complete, mix dependencies. The reason for that is there is this file run, which has different functions which are there. Run deps will install the dependencies, compile. Run server will start the IX session for it. Run setup will do all the setup that is needed, ecto migrations, things like that. So yeah, all this pretty much saves a lot of time. You can watch test as well from here, and this just run test watch, and it will run this command to reload the test once you have changed something. This makes your workflow very much easier, and you can use it as a GitHub template as well. And this can serve as a starting point for your journey into Nix. Yeah. So, oh, I had a slide for it. Okay. Yeah, this we have covered pretty much what all is there. And yeah, so all this, the good things about Nix. What we saw were the good things about Nix, what all niceties, good things that we get. But definitely this talk won't be complete unless we also see what are the bad things. The first one I would say is difficult to get into because of the unfamiliar syntax, because of so many different things. It's just there's a high roadblock over there, because of which a lot of people are hesitant to get started, right? But I would say, considering all the good things that you get out of it, it is definitely worth it. And I hope that through this talk, you understood how that barrier became a little less roadblock for you. So yeah, that is pretty much it. Thank you so much. If you have any questions or anything.
We actually, thank you so much for that talk. We actually have questions that have been presented. Let me just read through them. So the first question was, how limited is the external devices management?
Sorry, could you repeat? I didn't catch that.
I have a suggestion, Juliet.
All right.
Yeah, you can let the ask how the question, just ask the question.
All right, great.
Yeah, if they're okay with that. So Alfonso, if you can unmute and speak, if you're okay with that, then.
Sure thing. I just wonder how limited or how possible it is to manage external devices like webcams or hard drives or something outside the main board.
Okay. Right. So for that, what you would have to do is, for example, in Docker, we have the secure context, wherein if you allow the Docker container enough privilege to access the host's file descriptors, then it will allow it. In this case as well, if the host is providing those things, then you can use it inside the Nix environment as well. But it won't be fully reproducible because again, hardware is a different thing in each system. But yeah, it's definitely possible. But the limitation is that it won't be fully reproducible. It will be dependent from system to system. You can't guarantee that this will just work seamlessly across the systems. I hope that answers your question.
Yep, thanks.
Right, thank you so much. So there's another question by Ariane. I hope I've called your name correctly.
Hello.
So
like my question is that like you explained, so like does Nix directly like play with operating system of our system, like it's something like that?
Yeah, so okay. It's like Nix is a layer on top of your operating system. So the Nix code base, if you go in there and check, it basically it has all the logic written to connect with different operating systems. So Nix supports Mac, Nix supports Linux. What that means is that it has code that interacts with those particular drivers and whatever, etc., etc. And then once that layer is there, Nix provides you one more abstraction on top of it, wherein your code will run in that particular sandboxed environment instead of directly using the operating system level environment variable, shell, things like that. So yeah, in a way it does. You get a nice abstraction layer in between, which can be fully reproducible across systems so that you don't have to fully depend and access the global environment from your code. I hope I've answered that. Yeah.
Yeah, thank you.
Oh yeah, thank you. So we have Kalate.
Yeah, hey. Hi Raj. So in the talk, you've shown us how to set up a Nix environment for a project. But what if I want to set up a global Nix environment for my system? Like, is this possible? And if so, how would I go about it?
Yeah, that is actually, so when Nix the package manager was started, some people asked the same question, and that is what led to the development of Nix OS. So yeah, Nix OS is essentially you have your whole operating system described by the Nix code. So you can basically have a repository which says this is my operating system, and you can write Nix code to configure it. Like you configure your display, you configure your USB, things like that. And if you take that code and run it on any system with Nix OS, that system will be everywhere. That global configuration will be everywhere. So yeah, that is the question that led to the development of Nix OS. Yeah.
Interesting. I have another question. So is it possible to use Nix to manage dependencies for non-programming projects? Like for example, could I use Nix to manage the software tools and libraries needed for a data science or a ML project?
Okay. Yeah, I would say definitely, because at the end of the day, it's just software dependencies. And if you run those, data science or machine learning notebooks from a terminal, from a shell, then it will have access to all of those things provided by the shell. Actually, it has special, it would be much helpful as well, because I see folks who are starting with data science, machine learning, they get stuck. They see some tutorial online. It says that this uses TensorFlow 11, and then the next day or two gets stuck in installing TensorFlow 11. So I feel Nix has much more value there because you again get reproducible environments, which are crucial for things like data science or ML.
Right.
Yeah.
Thanks, Raj.
Yeah, thank you again. So it's nice that you explained how it came from the Nix project that it is to an operating system kind of. And that might be fusing with Alonso's question. which is, can you manage a disk partition or memory allocation using disk?
Okay, disk partitions or memory allocations. Interesting. So I'll be honest, I don't know. I mean, I would assume that in NixOS there would be a way to do that, but I don't know about it yet. Sorry.
Yeah, Alonso, feel free to ask a follow-up question on the same if you
If
do
you
have.
have any more suggestions, I actually would be, please do share about it, like, any problem that you have run into or how this can be done.
It's okay. I'm gonna be investigating about it.
Yeah, I would love to know as
Thanks.
well once you're done. Thank you.
Yeah, I can't see any more questions here. Raj, I have a question that I didn't type in.
Mhm.
So I've seen that you can install Python 2.7 and you can install Python 3. And that got me thinking about my disk space.
Mhm.
So how do it's so easy to install. How easy
Yeah.
is it to uninstall? How easy
Yeah.
is it for me to keep track of the packages that I do have on my
Correct. Yeah,
system?
that's a great question. So two facets to answer that question, basically. First is how to uninstall, right? Uh, to uninstall from the project, it's as easy as deleting this particular line, right? But deleting this line won't delete the files that are actually there for that particular, installation. So for that, Nix has something called garbage collector. So if you do nix garbage, I don't recall the exact command. Let us find nix garbage collect. Yes, yeah. So this is the command that you have. Basically, if you run this, it will go through your entire Nix directory. It will check which are the installations which are not being used anywhere, and it will just delete those. If you want to delete the entire Nix store, that is also possible. And if you just want to delete unused things, that is also possible. So yeah, I hope that answers your question.
Yeah, that makes me be easy now.
Yeah.
Yeah, thank you so much. Brian, you could ask your question. We have around 7 minutes to go.
Thank you. Thank you for this talk. This is really great. So when I do releases in production, I typically use mixed release. And what that means is that it typically recreates the entire environment, the entire Erlang and Elixir environment in a single folder. For me, that's like, it can make like a 10 gigabyte folder. Is this related to the last question? Like how do I like make sure that the releases are small? Is it that would Nix help with that, or are there like different methods I would use?
Yeah. Okay, so you're saying when you run Nix release, you are seeing 10 gigabytes release folders, is it? If
Yeah.
I understand. Oh, wow. Okay. Yeah, that seems odd. I mean, like, yeah, just with just your Elixir and Erlang, if they are up to date, that it shouldn't take that much space. But that's a different problem altogether. But in regards to Nix, what you can do is, I don't know, maybe your Docker container, or maybe, your setups installations steps, they are installing multiple versions of Erlang or Elixir. That might be an issue. And Nix can help with that, wherein you just specify which version you want, and it will just install that and nothing else. Because actually, an interesting anecdote about that, what happens is when you are done with the application, you want to deploy it to production, and then you write your Docker file or your GitHub action, it goes there and it just doesn't work, right? It says this is missing, that is missing. So what you do is you just add things until you get it working, because you have to deploy it to production. It is time to release. And once it gets working, you forget about it. But you don't realize that there are a lot of things which are actually unnecessary in the code that you have written, right? Because you write apt get this, apt get that to support your Erlang installation. Nix just makes it easy by installing all the transitive dependencies by itself without you having to write it manually.
Thank you. I should add the project is a mix of Elixir and Python. So maybe that's also why.
That would answer some questions. Yeah.
All right. Thank you so much for the questions. I'll hand it back to Juliet.
All right. Thank you so much for everyone that's managed to participate today. We thank you so much for the questions. As for Raj, we also appreciate that you were able to join us for this talk. I believe that each and every one of us has left with much more content, and we can be able to explore NICS at a better rate at the moment. We thank you so much for your time. Hope that you do have a lovely rest of the day. And the video is going to be up before Monday, give or take. So for those who might want to actually check up on things, you can be able to get the video from our social media pages, which is going to be in Elixir Kenya. We thank you for today and do have a lovely rest of the day.
Thank you so much for
Bye.
having me.
Thank you so much, Raj. That was wonderful.
Thank you.
Looking forward to seeing you again.
Yes.
All right.
Definitely.
Bye-bye.
All right. Bye, everyone.